as part of educating people on the key downside of the product and services we use, some of the severe implications it has on our life. In today's episode, we are going to look at a very beautiful product that everybody wants to utilize. I mean, Starlink. But before then, I want you to listen to the rest of these amazing backgrounds, and I'll be with you shortly. Hello guys, welcome to another amazing episode of Podcasting with Techie. In this episode, we're going to look at a very amazing product that everybody wants to utilize. We're going to look at the huge downside and the severe implications it has on our life, on our planet. We also have to know that our Starlink, the satellite internet service by SpaceX, has been praised for providing high-speed internet in remote areas. It also has several significant downsides. And these significant downsides is what we are going to look at today. I know there are a lot of beautiful, episode content about Starlink, praising and talking about the good aspect of it. But in this episode is going to be the opposite of it, because we want to look at the technical aspect of Starlink, how it's impacting people in terms of health, environmental, astronomical, and a whole lot of things. It's going to be from the down to the top. We're going to look at a small downside, the less severe implication, and we go to the more severe aspect of these episodes. The severe aspect of Starlink. First of all, Starlink, you have to know that if you're trying to get a Starlink is an amazing product, but it's also very expensive. The initial setup fee for the Starlink kit, the satellite dish and router is relatively high, and the monthly subscription cost can also be steep compared to traditional broadband services, making it less affordable for some users. So Starlink, in a nutshell, is very expensive, and it comes with monthly subscription. So if you're trying to get Starlink, then these are some of the things that you should look at. And then we are looking at scalability and capacity. So as more users subscribe to Starlink, concerns about network congestion and reduced speed arise. The network's capacity might struggle to keep up with growing demand, especially in densely populated areas. So as everybody wants to get Starlink, as it stands now, almost 100 plus countries has licensed Starlink. It's very beautiful. Recently, we've seen Fiji license Starlink, and it's an amazing thing that everybody is happy about. But we also have to look at the downside, the severe implication it has on our life. We are going to look at environmental impacts. This, together with a few topics, is what we are going to look at: the environmental impact. The launch of thousands of satellites contribute to space debris. So space debris is going to be a standalone topic that we're going to discuss in this podcast for you to get an understanding of what space debris and how satellite is impacting space debris, which poses risks for other satellite and space missions. Managing and mitigating space junk is growing concern for the global space community. So this is some of the things we are going to look at. And we are also going to look at astronomical interference, the bright reflection from satellites, like the Starlink, interfere with astronomical observation, making it difficult for astronomers to study the night sky. This impact on ground-based telescopes has led to significant pushback from the scientific community. So there are a lot of concern about satellites, a lot of concern about Starlink that we have to look at. A lot of people don't mostly care or think about some of the bad side of the disadvantage of the product that we use. We all want to enjoy the product, and it's beautiful, it's an incredible thing. I'm not against it. But we have to be very critical in our thinking. We have to be very critical in the things that we want to get and utilize. Because some of the things in the surface is very beautiful, it's amazing, it's incredible. But when you are diving deeper, you get to understand that the impact it has on human life is huge. And Starlink happens to be one of these things. So you're going to dive deep into this so that you get understanding of what I'm trying to say. And we're going to look at weather dependent. Starlink's performance can be affected by weather conditions such as heavy rain, snow, or dense clouds, potentially leading to intermittent service interruptions. So if you're somebody who is trying to get Starlink, just know that it's a weather dependence product. So Starlink performance can be affected by any weather condition, such as heavy rain, snow, dense clouds, potential leading to intermittent service interruption. So you should know that, there are a lot of things that happens, in the universe. Outside this planet, there are a lot of things that happen. So you should know that Starlink is orbiting. So a lot of things are going to, affect it in terms of weather and a lot of stuff. So we have to look at that. And there's latency issues. So we have high latency and low latency. And we are saying that Starlink is a low latency. But let's look at the downside latency of Starlink. While Starlink offers lower latency compared to traditional satellite internet, it still doesn't match the low latency of fiber optic broadband. So if you're somebody who is trying to get, Starlink, just know that Starlink still doesn't match the low latency of fiber optic broadband, which can be a drawback for activities requiring real-time data transmission, like online gaming or video conferencing. So if you're looking to purchase Starlink, you should know that these are some of the things that you have to pay attention to, because you have to know what you're getting. If you're going to spend $600 plus, or maybe 10,000 Ghana cedis plus, or whatever amount it is in your currency, then you should know that it's something that is worth it. Otherwise, you're just going to throw your money away. Even though they are improving on the services, it's going to take some time. So it has a latency issue, and they have to look at that. And 7, regulatory and licensing challenges. Deploying and operating a global satellite network involves navigating complex regulatory landscapes and obtaining necessary licenses from various countries, which can be a significant hurdle. But this is not something that we're going to, this is, to the company. So we don't really care much about this. And we're going to move to monopolistic concerns. As Starlink grows, there are concerns about SpaceX becoming a dominant player in the satellite internet market, potentially facing competition and innovation. In this episode, we are not going to look at monopolistic concerns and regulatory and licensing challenges. We are going to look at the environmental impact, and also going to look at astronomical interference, weather dependence, latency issue, and then we go forward from that. These downsides highlight the challenges and limitations that come with the development and operation of a large-scale satellite internet. So, service like Starlink. And then this is what we are going to look at. So first of all, we are going to look at more vivid explanation of the third and the fourth. And that has to do with the environmental impact and the astronomical interference. And then from there, we go to weather dependence and latency issues. Environmental impact. Space debris and risks to space operations. Starlink plans to deploy tens of thousands of small satellites into Earth's orbit. LE. This massive increase in the number of satellites significantly raises the risk of space debris. Space debris, this is what we are going to look at. Here is a vivid picture of the problem I'm trying to present to you. The first one is crowded orbits. Just look at crowded orbit in this way. Imagine a busy highway packed with cars moving at a high speed. Each satellite in orbit travels at roughly 17,500 miles per hour. Every Starlink satellite travels roughly 17,500 miles per hour. With so many satellites close to proximity, the likelihood of collisions increases. Even a minor collision can create thousands of tiny fragments, each capable of causing serious damage to other satellites. If a collision occurs, it can create a cloud of debris that might collide with other satellites, creating even more debris in a cascading effect. This phenomenon, known as the Kessler syndrome, could render certain orbits unusable for decades, several impacting space operations and future missions. So, this is what I'm talking about. There are things that we really need to look at. We shouldn't always look at the good aspect of the product that we are using. Sometimes we have to dive deeper into some of the effect it has, the overall effect it has in the long run, not what we are enjoying today. So it's very, very important. So we are going to look at space traffic management. Managing and tracking such a large number of satellites becomes an immense challenge. See this? The space agencies and companies must constantly monitor the positions of these satellites to prevent collisions, which requires advanced technology and international cooperation. So look at collision like an accident. You understand what I'm saying? Look at collision like an accident. That is where if something collides, it means that they collide with something. So just look at you kind of crashing with somebody, or maybe having an accident with your car, maybe your bike or whatever it is. So that is the collision you are talking about. So we really look at, so that is the collision we are looking about. And we are also going to look at astronomical interference. We're going to dive into this. So if it's something that you don't understand, you're going to get an understanding of what astronomical interference is all about. So impact on ground-based astronomy. Astronomy is all about the study of the universe. So that's what they're trying to say, astronomical interference. And so the impact on ground-based astronomy. Starlink satellite, especially when they are newly launched and still adjusting their orbit, can be very bright, very, very bright. It can be very, way bright. They reflect sunlight, creating streaks of light that interfere with observation from ground-based telescope. Here's how this plays out. So you're going to learn about how this plays out soon. You should know that Starlink, when this product is newly launched and still adjusting their orbit, they can be very, very bright. So you yourself just imagine looking at a very bright sun. You know that you have to close your eyes some way at some point. You cannot even look at it. You have to wear sunglasses or something. Even though we are on Earth, there are people who are outside it, studying the environment. learning more about weather conditions so that we can get understanding of what the weather is going to be in the next minute, the next hour, the next day, the next month. So if people, or let me say astronomers, are not being able to read the weather, it's going to be a problem. So you should know that they reflect sunlight, creating streaks of light that interfere with observation for ground-based telescope. This is how it plays out. One, it ruined observations. Imagine astronomers trying to capture a clear, detailed image of a distant galaxy. So if Starlink is going to be too bright to the extent that people or astronomers cannot read, take, shoot, capture images that are very clear, detailed image of a distant galaxy as they take long exposure photograph, a Starlink satellite passes through the field of view, leaving a bright streak across the image. This streak can obscure or distort the data, making it difficult to study celestial objects. So this is one of the bad side of Starlink, and then we have to look at it very, very critical so that we get understanding of what Starlink is doing, and then we know if it is a product that we have to continue using or not, or maybe if we have to, educate people on these kind of things so that we can all support the development and the positive growing of products that we use. Cumulative effects. We have to know that it has to also have cumulative effect. With thousands of satellites, the probability of such interference increases. Multiple satellites can crisscross the sky, creating numerous traces in astronomical images. This is particularly problematic during the twilight hours when satellites are most visible, but astronomers are also conducting important observations to see what Starlink is causing. With thousands of satellites, and we know thousands of satellites has been, projected already, has been sent already. So with thousands of satellites, the probability of such interference increases. Multiple satellites can crisscross the sky, creating numerous streaks in astronomical images. This is particularly problematic during the twilight hours, when satellites are most visible, but astronomers are also conducting important observations. This is what Starlink is doing, and then we have to really pay attention to it. It also impacts on research. It has impact on research. We have to also know that the interference affects not only visible light astronomy, but also other wavelengths such as radio astronomy. You should know that very important. Starlink satellites can emit radio frequencies that interfere with the sensitive equipment used to study cosmic phenomena, making it harder to detect faint signals from distant objects. So this is one of the things that Starlink is doing to the universe, and we have to know about it. It's not about enjoying the good aspect of it. Sometimes let's dive deeper. How is it impacting the universe at whole? How is it impacting our lives? What are some of the things that we really have to pay attention to? Is it all about enjoying the product, or is it also about knowing the deeper aspects of the product? It also has a mitigation effort. It has mitigation effort. SpaceX has attempted to mitigate this issue by darkening the satellite with sunshades and adjusting their orbit, even though they're trying to provide a solution to this bright, aspect of the Starlink. But however, these measures are not always fully effective, and the sheer number of satellites still poses a significant challenge to astronomers worldwide. You should know that Starlink is almost everywhere, 100 plus countries now, and they are orbiting. So this is a very big problem, not only in the US or in Australia or in Spain or Germany or UK or Ghana, Nigeria. No, everywhere in the world. So as these satellites are too bright for astronomers to read, the universe, know what is happening, know what is coming, celestial bodies is also a big problem. So in summary, the environmental impact and astronomical interference caused by Starlink satellite constellation present serious challenges. The risk of space debris threatens the safety and sustainability of space activities, while the interference with astronomical observation hinders scientific research and other understanding of the universe. And then, as I said, we are going to look at space debris. What space debris is, so that you get understanding of what you are trying. I'm trying to, let you understand. And space debris is a critical issue that every satellite company is battling with. What is space debris? This is space debris. Space debris, also known as space junk. Junk, when, something are not working anymore and they throw it away. It can be on a dump site or whatever it is. So as you know that when we have junks and we throw it away, there are a lot of junk in space as well. But in this case, it's worse because, you cannot go and collect these junks. Not like the things we have on Earth where, junks from cars and products and other things can be, crushed into small pieces and also used to manufacture other things. In this case, it is very difficult for people or satellite companies to go and collect these junks and bring them back to Earth. So you should know this. The space debris, also known as space junk or orbital debris, includes different satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions. These objects orbit Earth at high velocities and range in size from tiny flakes to large, inactive satellite and rocket bodies. So it is said that 50% of the satellites we have in the universe, 50 of them are dead. So they are junk. In the right words, in the right cyberpunk word, like they are junk. 50% of the satellite we have are junk. And then, this is a very big problem that people are really facing. So space junk, the orbital debris increase. So we just know how to do this. It's very important that we know that as the space debris increases, it poses a very strong environmental problem to our planet. And then it also creates a lot of problems. We are going to dive deeper into space debris, the danger of high-speed collisions. So just imagine a tiny piece of metal, the size of a marble, hurtling through space at a speed up to 7,500 miles per hour, 28,000 kilometers per hour. At such speed, even small objects can cause catastrophic damage upon impact due to the enormous kinetic energy involved. A collision with a small piece of debris can puncture spacecraft, disable satellites, and endanger astronauts' lives. So I'm going to give you an example of space debris events. I'm going to give you about 3 examples that happened, in the previous years. The first one is the Fengyun 1C incident. It happens in 2007. The Fengyun 1C incident happened in 2007. In 2007, China conducted an anti-satellite test, destroying the Fengyun 1C weather satellite. This single event created more than 3,000 pieces of trackable debris. In other words, 3,000 trackable junk orbiting the Earth, significantly increasing the debris population in low Earth orbit, LEO. This is one of the problems we are talking about. The second, we have the Iridium Cosmos collision, which happened in 2009. In 2009, an active Iridium communication satellite collided with a different Russian Cosmos satellite. This collision produced over 2,000 pieces of debris, large enough to be tracked, with many smaller, untrackable fragments also generated. So 2009, together 2007 was more than 3,000 pieces of trackable debris, so junks. And now 2009, 2,000 plus, making 5,000 trackable debris large enough to be tracked. What about the ones that were small, not to be able to track? And these are, with a very high speed. So we have to know this. They take a fragment and microparticles, paint, flakes, and tiny metal fragments from satellite erosion or minor collisions also pose risk. These small particles might seem insignificant, but can damage spacecraft surfaces and windows, compromising machines and equipment. So SpaceX is also capable of all this problem. So let us know that the satellite, the Starlink, is also causing a very big problem to our planet. So we're going to look at, let us look at Kessler syndrome. This is a problem that is going to cause by the Starlink satellite. So you have to look at it. Let us weigh the advantage and disadvantage this has on our lives, so that we can, make good decisions. Otherwise, tomorrow we are going to face a very big problem that, we may not be able to solve. Because as we are always enjoying these kind of things, let us not also forget that they poses risk. Envision a chain reaction where one collision creates debris that leads to more collisions, generating even more debris. This scenario is what we call the Kessler syndrome or the Kessler syndrome. So describes a cascading effect that can make certain orbits unusable for years or even decades. The increasing density of debris exponentially increases the risk of further collisions, potentially leading to a debris belt. A debris belt. This is another topic we're going to look at. It's very, very important. What is debris belt? We're going to look at that, and you're going to be marveled, enjoy this episode. I know we are enjoying this episode. It's very educational that we have to listen to it, enjoy it. There are a lot of things that our products are causing, so you don't only look at the good side of it. Debris belt that envelopes the Earth, severely hindering future space missions. So challenges in mitigating space debris. When companies are trying to mitigate space debris, there's a very big challenge. So tracking and avoidance. So if they're not able to track these things, they can, it's going to cause problem tomorrow. Maybe not today, but it can cause problem to other satellite, cause problem to spacecraft and a whole lot of things. So space agencies and private companies constantly track over 27,000 pieces of debris larger than software. They perform collision avoidance maneuvers to protect active satellite and the International Space Station, ISS. However, many smaller objects, which are still dangerous, remain untracked due to the size. So it is what it is. And then two, we are going to debris removal. Efforts to actively remove debris, such as using robotic arms, nets, or harpoons, are still in experimental stages. These technologies aim to capture and deorbit debris, reducing the risk of collisions. However, the sheer scale of the problem makes this a monumental task. So yes, they are finding ways and means to remove space debris, but it's also a problem because there are no technologies that are doing so right now. So we have to be very careful with all these kind of things. Regulations and preventions. International guidelines and regulations aim to limit the creation of new debris. This includes designing satellites to deorbit after their operational life, ensuring rockets don't leave spent stages in orbit, and avoiding international destruction of satellites. So this is what we are talking about, and then we have to be very careful When using this satellite, Starlink is beautiful and amazing, but we have to look at the downside of it. Look at the severe implication it has on us. So that is what I'm talking about. So let's look at a very vivid analogy. Vivid analogy. So let's think of Earth's orbit as a vast ocean filled with ships, both functional and abandoned. So now imagine that every ship, when it breaks apart, releases countless high-speed shards that can punch holes in other ships. Maintaining safe navigation in such an environment becomes exceedingly difficult and dangerous, akin to space operators dealing with space debris today. So it's the same thing, having ship on top of sea, some being active, functional, and some abandoned. And these ships, when it breaks apart, releases countless high-speed shards that can punch holes in other ships. What do you think is causing? What do you think that is going to happen? Maintaining safe navigation in such an environment becomes exceedingly difficult and dangerous, akin to space operators dealing with space debris today. So in summary, know that space debris poses a significant threat to the safety and sustainability of space operations. The risks of high-speed collisions, the potential for cascading debris creation, and the challenges in tracking and removing debris all contribute to a complex and pressing issue that space-faring nations and organizations must address collaboratively. And then in our conversation, we talk about debris belt. Debris belt covering, our planet. So what the debris belt is creating. So just look at a concept like this. Concept of the debris belt. Let's look at the concept like this. So the debris belt refers to a dense, that's what I'm trying to let you know, ring-like accumulation of space debris orbiting the Earth. This belt consists of countless pieces of debris. In other words, junk. I want you to know that. Ranging from tiny paint flecks to large defunct satellites, all moving at a high velocities in various orbital paths. The presence of such belt poses a significant threat to both current and future operations. So this is how it forms, formulation and evolution of the debris belt. This is how it forms. I want you to know this is how it forms. 1. Sources of debris. The debris belt is formed by several sources. Defunct satellite, old non-functional satellite left in orbit after their missions end. After satellite missions end, they leave the junk in space, called debris. They leave the junk in space. So spent rocket stages, let's say booster stages and other parts of rocket that remain in orbit after delivering their payloads, collision fragment, pieces generated from collisions between satellites and other debris. So leaving this junk can, cause problem to other satellites that are even functional and active. And they create this debris. Explosive disintegration. Explosions of fuel tanks or batteries in orbiting spacecraft. These are how, debris are created. That's what I'm trying to let you know. Operational debris. Small parts, such as bolts or paint chips, shed during normal satellite operation or maintenance activities. So know this. High-speed collisions. Objects in the debris belt travel speeds up to 7,500 miles per hour, 28,000 kilometers per hour. At this velocity, even tiny fragments can cause significant damage. When collisions occur, they generate even more debris, exacerbating the problem and contributing to the belt density. The high-speed collision These are very high speed. Yeah, in a very high speed. This is a very big problem. And cascading effect. Let's look at cascading effect. The Kessler syndrome that we looked at, in the previous parts of this episode. The Kessler syndrome illustrates how one collision can trigger a chain reaction. For example, if a satellite is hit and breaks apart, the resulting fragments can collide with other objects, creating even more debris. Over time, this process can lead to a densely packed debris belt. Risks and challenges of the debris belt. These are some of the risks and challenges of the debris belt. One, safety of active satellites. Satellites in the debris belt are at constant risk of being hit by debris. In other words, junk, even small pieces, can puncture satellite surfaces, disrupt functions, or render them inoperable. Threats to manned missions. The International Space Station, ISS, and other manned spacecraft must navigate through the debris belt. It means that they have to drive through the debris belt. The problem that are going to be caused by Starlink, the International Space Station, and other manned spacecraft must navigate through the debris belt. The collision with even a smaller piece of a debris could be catastrophic, endangering the lives of astronauts. So what I'm talking about is not a small issue. It's a very big issue that we have to look at, but people are not really paying attention to it because we cannot see. But let's imagine there's an accident in our universe. Where is it coming? It's coming down. So we should know. There's one event that happened some years ago where a satellite fell on somebody's building, caused a catastrophic, problem to the person. So you should know that future space missions. The debris belt poses a significant challenge for the future space missions. Launching new satellite or manned missions requires careful planning to avoid debris collisions. So now we have to be very careful when, a satellite is moving from Earth to space. That's very careful. As the belt becomes more populated, finding safe path through it becomes increasingly difficult. The Starlink is creating more satellite. Starlink, pushing to the air. Some of them are going to die, and they will replace it. When they replace it, cannot collect these things, and they are going to be debris, going to be junk left over there. They're going to be overpopulated. It's going to be a problem to future, space missions. So it's a problem. So let's visualize the debris belt. So a crowded highway. Imagine a highway packed with cars moving at incredibly high speed. Now imagine that some of these cars break apart, scattering pieces everywhere. As more cars enter the highway, the risk of collisions increases, and every new collision adds more debris to the already crowded space. This is analogous to the situation in orbit. It's a very big problem. A spinning gauntlet. Picture an astronaut trying to cross a room filled with rapidly spinning blades. Each blade represents a piece of space debris, and the astronauts must navigate carefully to avoid being hit. You have to dive like a fish. Ew. So this illustrates the danger faced by spacecraft moving through the debris belt. So as we are using Starlink, everybody wants to get Starlink. The speed are going to be reduced, and as the speed reduced, they are going to create more satellite, Starlink, and send them to space, and these are going to be added, create a lot of problems. Let's not look at the beauty of it today. Let's look at the bigger picture, mitigating the debris belt. If you are mitigating the debris belt, tracking and monitoring, space agencies use radar and telescopes to track large pieces of debris. This data helps predict pollutions, potential pollutions, and allows other invasive maneuvers, debris removal technologies. So they are creating a lot of technologies that can help them remove the germs from the space. But it's not an easy thing. It's not an easy thing because it is now, that is why they are creating these robots and all of that, to be able to go to space and remove or collect this, debris or germs. But they are still in development. So debris removal technologies, innovative solutions like robotic arms, nets, and harpoons are being developed to capture and remove debris. However, these technologies are still in experimental stages and face significant technical challenges. So it is not something that we are going to pull off anytime soon, even though we're gonna, finally come up with a very good solution. But until now, we are still fighting. So international cooperation, the global nature of the debris problem requires cooperation among space-faring nations. International guidelines and agreements aim to prevent the creation of new debris and manage existing debris responsibly. It's a very big problem. Design improvement. Future satellites are being designed with debris mitigation in mind. This includes features that allow them to deorbit at the end of their life or break apart into less harmful fragments. When are we coming up with this, technology or design? In summary, the debris belt represents a significant and growing challenge for space operations. Its formation through high-speed collisions and its potential for causing further collision make it a critical issue to address, and mitigating the risks associated with debris belt are essential for the safety and sustainability of current and future space activities. Let's quickly look at some of the weather dependence. We all know that Starlink depends on weather. It's a weather dependence. It's a satellite, so it's a weather dependence. So let's look at the weather, how weather can affect the Starlink satellite. Let's look at them. And when they are being affected, your internet is also being affected. So how weather affects Starlink? This is what we are going to look at. Starlink, like other satellite internet, service, relies on signals transmitted between ground stations and satellite in low Earth orbit. These signals can be disrupted by various weather conditions, leading to intermittent service interruptions. So here is some detailed look at how weather impacts Starlink. First of all, rain feed is the first one. Rain feed, the rain feed mechanism, the first one. Rain feed refers to the absorption and scattering of radio frequency signals by raindrops, particularly at a high frequency used by Starlink. What are the impacts? During heavy rain, the signal strength can decrease significantly, causing slower internet speeds or complete service outages. Users might experience buffering while streaming videos, slow web page loadings, or dropped connection during video calls. Snow and ice. Accumulation of dish. Snow and ice can accumulate on the dish. So if you're in a country that snows, snow and ice can accumulate on the satellite dish, obstructing the line of sight between the dish and the satellite. The physical barrier prevents the dish from receiving and transmitting signals effectively. The impact: users might need to manually clear snow or ice from the dish to restore connectivity. Starlink dishes have built-in heaters to melt snow, so it's a very good thing. But now, in a very heavy snowfall, manual intervention might still be required. So if you are in a country that snows, you should know this if you want to get a Starlink. Cloud cover and fog, signal absorption and scattering. Dense clouds and fog can absorb and scatter satellite signals, weakening the transmission. You understand? And the impact, while not as a severe rain feed, heavy cloud cover and fog can still degrade signal quality, leading to slower internet speed if you're trying to get the Starlink. The thunderstorms and lightning also affect it. Electromagnetic interference. Lightning generates strong electromagnetic pulses that can interfere with satellite signals, and that includes Starlink. Impact. Thunderstorms can cause brief service interruption and signal degradation, affecting internet reliability and during severe weather events. Impacts. Thunderstorms can cause brief service interruption and signal degradation, affecting internet reliability during severe weather events. So let us visualize weather dependence. So imagine trying to have a conversation with someone using a walkie-talkie through a thick forest. When it rains heavily, the raindrops can dampen the sound, making it hard to hear. Similarly, thick fog or snow can muffle the sound even more. This is akin to how weather conditions can disrupt the weather path, can disrupt the clear path needed for satellite signal to travel effectively between your dish and Starlink satellite. So you're looking at the latency. People are saying that, oh, Starlink has latency, low latency. That means that the internet is very good and blah, 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 blah. Know this. I want you to know this, that even though it has a very low latency, there are things that you need to understand about the latency you're talking about. Otherwise, they're going to buy something you know nothing about. So latency issues. Let's understand latency. Latency often referred to as ping. So if you have internet in the olden days, if you want to look at the speed of the internet, we're just going to write ping, then you add the IP address of our internet. These days we stop using that, but they still use it. So latency often referred to as ping. Referred to as ping. Latency often, so understanding the latency often referred to as ping is the time it takes for data to travel from the user's device to the satellite, then to a ground station and back again. It measures in milliseconds. Lower latency is crucial for real-time applications like online gaming, video conferencing, and VoIP calls. So VoIP calls is used by the WhatsApp, the Facebook, and other platforms that help us to make calls. That I can cause this too. Latency in Starlink versus traditional broadband. Know this: if you have this traditional number like the MTN, Vodafone, and all of that, the AT&T, the T-Mobile, some of them has the traditional broadband. That's So let's look at the Starlink latency mechanism. Starlink satellite orbits at about 550 kilometers, 340 miles above Earth, significantly lower than traditional geostationary satellite, which orbits at around 35,000 kilometers, 22,000 miles. This lower orbit helps reduce latency. Typical latency satellite. So this is a typical latency. Starlink generally achieves latency between 20 to 40 miles, which is lower than traditional satellite internet, but higher than fiber optic broadband. So fiber optic broadband mechanism. Fiber optic broadband transmit data using light through optical fibers, achieving near light speed data transmission. So a typical latency. So know this typical latency. Fiber optic broadband typically has latency under 10 milliseconds, providing faster response time for real-time applications like the MTN, the Vodafone, the Tigo, the Teltigo, the AT, all of them has this fiber. So this was a problem that we faced, a few months ago when there's a problem with our the fiber underwater fiber that they had to work with. So and then these are impacts of latency on applications. So let's say if you're an online gamer, know that in real-time data is very important. So online games require real-time data exchange. Higher latency can lead to delays in player actions, causing a laggy and frustrating gaming experience. The impact it can impact gamers using Starlink might experience slightly delays compared to those on fiber optic connections, which could be critical in fast-paced games. If you're looking to buy Starlink, know that this is a problem with your gaming. It's going to affect your gaming huge. Know what you're using Starlink for. Don't just rush and pay $600 plus or $10,000 plus to buy a Starlink if you're a gamer. Gamers using Starlink might experience slight delays compared to those fiber optic connections, which could be critical in fast-paced games. Video conferencing. Two-way communication. Video calls require low latency to maintain natural conversation flow. High latency results in awkward pauses and talking over each other. Impact. So Starlink latencies, while better than traditional satellite internet, might still cause noticeable delays compared to fiber optic broadband, affecting the quality of video conferences. So as I said, we are going to look at the VoIP calls. This is what's used by WhatsApp and the rest of the apps that helps us, with video calls and all of that. Voice transmission. Under VoIP calls, I have voice transmission. So voice transmission, a clear and immediate voice transmission is essential for VoIP calls. High latency can lead to echo, delays, and disrupted communication. The impact Starlink higher latency compared to fiber optic can affect call quality, making conversations less smooth. So let us visualize latency. Consider latency as the time it takes for letter to travel back and forth between two distant cities. With fiber optic broadband, it's like using a supersonic jet. So letters, data, in other form data, travel almost instantaneously. With Starlink, it's like using a high-speed train. Still fast, but not as quick as the jet. For real-time communication, even this slight difference can be noticeable and sometimes disruptive. So in all, know that while Starlink offers many advantages, weather dependence and latency issues are significant downside. Weather conditions like rain, snow, and clouds can disrupt services, and the inherent latency, although improved over traditional satellite internet, still falls short of the near instantaneous response times offered by fiber optic broadband. These factors can impact the reliability and performance of Starlink regularly for real-time applications and during adverse weather conditions. So thank you guys for listening to this amazing podcast. Thank you for listening. And then if you enjoy this episode, I want you to know that you can follow me on TikTok, Instagram, Facebook, and I'll be very grateful if you can subscribe to my channel, Baby Techie, on YouTube. And there's also Baby Techie _ on TikTok. I have Baby Techie on Instagram, and you can follow me at God Bless Media on Facebook. Just stay tuned, subscribe to my podcast, and then you get to enjoy every good aspect of it. Thank you. Bye-bye.